This is the wiki where I maintained the findings and discovery with regards to converting an ancient and mysterious C algorithm into Java. We received this C algorithm from the PACT team, PACT, PACT team, and they use this C algorithm to generate ID. I think that the ID generation has tight, somehow has connection to database lookup. I am not sure what for specifically, but maybe for speed or just to for association. The C code was written in 1998, so it was a relatively old code, and this is the original C code. Sorry, this is the original C code when we received them. When we first received the C code here, original copy, the algorithm is here. There's only one function, and that is the algorithm that we are talking here, and that is the ID generation function. It accepts, I think, 11 input parameters passed by reference. That is, the function will modify the parameter, and the modification will be visible from the calling function. This is not directly doable in Java, but we'll see. So this is the algorithm. Now, it did not run upon receipt because there were some C constructs that was very old and did not please the modern C compiler of today. So there were some cleanup, but minor, but delicate enough so as not to affect the algorithm or the flow or to change the behavior. Somehow we were able to clean that C code and compile that successfully and make it run to produce output. They also gave an input file containing 72 lines. This file each line are test cases. So there are 72 test cases. I think the 72 test cases covers a lot of grounds in terms of what is possible, in terms of input. And so when we ran this feeding that input file, the C program spit out a result, this one. And the converted Java, after converting it to Java, I also verified that the Java converted equivalent spitted the same output. So in this output, entry 1, test case 1 was a successful ID parameters. Test cases 2 to 6 are invalid ID parameters, and these are the reasons why they are invalid. Test case 7 is another a successful ID parameters. Test 8 to test 11 are invalid parameters, and these are the reasons why they are invalid. So the Java equivalent both produce the same successful ID that is generated as well as the errors that it found, hence proving that the conversion was a success. There is 0.1% of the algorithm that is not, I have not yet internalized clearly, only 0.1%, but we don't need to 100% understand the algorithm. All we need to do is just to mimic the structure of the algorithm and provide the necessary scaffolding to trick the Java runtime that it has the equivalent function as it appears in C. So this is the converted Java. And so this is the algorithmic function of concern, ID gener. In C, these are passes function pointers, but in Java, these are passed as character arrays, this as the closest equivalent. And because Java does not accept pass by reference, the nearest construct that Java can approximate that behavior is passing an object, because an object, the changes made into the object is visible from the caller. So the readable class is here. And so instead of passing these individual fields as parameter, we pass that inside an object, so that whatever is written into this object shall be visible by the caller and thus simulate the same intent as it originally appeared in the C algorithm. Furthermore, Java has no strcmp, so we trick by creating the necessary scaffolding to simulate this C API call. And strncmp, it also has no ASCII to int, so we simulate that it also has no sprintf and so on, even as digit, but they have they can be recreated with Java equivalent constructs. But the result of creating this scaffolding is that the converted Java code looks almost exactly the same as the C code. So this is now the Java code, and if you compare this to the original C code, they almost look the same, especially on the innermost parts with regards to looping and checking of certain conditions which are vital to the algorithm, it seems. So even the spaces and the brackets, I preserve it to make the converted code the same as it appeared in the C, except for some unavoidable differences, like a Java, I have to call the to-car array, but 99% the code looks like the same. For example, the placement of is digit calls and the indexing of the character array. This is how it looks in the original C code, and thus I save myself from the burden of assuring myself that the converted code is exactly the same. Just create the necessary scaffolding and we trick the Java code that those functions are there, and therefore we can recreate the C algorithm. Now there's also a wiki here. And after converting the Java code, first converting the C to Java, and Java creating SCA, SCA, BPM project module, it now becomes a SOAP service wherein the parameters being passed are readily testable using the integration designer's tester interface. I only created 7 test cases out of 72. For example, this one, A is the prefix, the record type, the ID prefix is X, the low ID is AAA, high ID is DDD, the ID suffix is Y, and so on. And as soon as we click this play button, these particular ID parameters are fed into the algorithm, and the Java converted code will generate either the next ID if the parameters are valid, or an error if something was wrong in the given parameters. So this is also the zip module, which I attached in this GitHub repository. You can unzip this and try it in your local development. I also renamed the file name to resonate and to associate more clearly to where it was coming from. The original file was factfeds.c, so it only is a good choice to rename it also to factfeds.java, as well as the ID general function is preserved. And these are the was logs. So in this particular input, the next ID is ECA. Given these parameters, the ID low, the ID high, and the last use ID and the inclusion characters, the next ID, if those are the parameters, the next ID is ECA. On other test scenarios, something was wrong and error text described that accordingly. This is also the same error description when the original C code was run, and thus both success and error are being produced between these two equivalent code. Going now to the IDE, I'm not yet sure if the SCA module is the best place for this. ECA module is a SOAP service, and if a large number of parameters are passed into it, it could become a bottleneck. But given that if it is not a bottleneck call, then a SOAP module would be fine because you only provide parameters in the here in the request object. These are the fields, and the output is written into the SOAP response object. And this is the generated code using static classes to avoid unnecessary garbage collection, except for the retrieval. And so this is not yet finished. The return field is null, but the last thing to do here is to wrap the output in retrieval and return it inside the ID general response SOAP message. So this is the class. This is the actual class from the converted code. This is exactly the same as what we viewed a while ago. I just cut and pasted the contents here, exactly the same, except that I commented the main entry point, because this time it is already running inside WebSphere environment. So these are warnings because these variables are not used as are harmless, and these are the errors. An exact cut and paste from the C code to preserve the same mapping of error code versus what the error is about, and so on. So, and this is the pack module. It is a Java type, not a BPL type, appropriately because this is an algorithm. And let us give a test. For example, let us do a tail. Right? Then let us open an exerciser interface and maybe fire this particular test case. The value of this particular test case are here. Let me rerun this test case. And indeed, it produced the next ID. Let us rerun the second test case, which should produce an error. And these are the test case values. The error is because X is not a valid record type. Let us rerun his one. See, X is not a recognized record type. Only A, G, and L are valid record types. The complete output, by the way, the complete test cases, by the way, is here, and the complete output of those are here. So this is the first test case we just saw. It was successful, and this is the second that we saw that it failed. I only created 7 test cases here in my integration designer, but I already tested the algorithm to the with the 72 test cases in this file already in the command line. So it should be the same. The to do here would be like API design changes, how the ID generation is invoked from other subsystems if a file is given, or whether it is part of a tight loop, so performance is an issue, and so on. Those are actually something to think about later on. That's it.